Welcome you all. So in this session, we are going to discuss about the die casting process. Die casting is one of the permanent mold casting process in which the molten metal is injected into the die at high pressure. So here the dies are made up of the permanent dies are made up of a metal. There is a permanent die. So whereas in sand casting or the shell molding the investment kind of casting processes, we use a expandable mold. That means once the casting is completed, once the solidification process is done, the 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 external that mold will be destroyed and the final product will be taken out. So this is the kind of process. I think it is called expandable mold process. Whereas this die casting process comes under permanent mold where the die can be used multiple times. Okay, so the die casting is closely related to a permanent mold casting in that both the process use reusable metallic dies. So you can cast. The casting can be done many times. Okay, there won't be any destroy of materials. So in die casting processes, the metal is forced in under pressure compared to permanent molding. It is also called pressure die casting. In permanent mold casting, there are many types are available like gravity die casting, low pressure die casting, under high pressure die casting, and sluice casting, slush casting, video casting. So there are many types of permanent mold castings are available. But here the die casting, so die casting means it's pressure die casting. Okay, there is a low pressure die casting processes are also available. But here the term die casting represents pressure die casting because here the material, the molten metal is injected into the mold under high pressure. Okay, so why the high pressure is applied? Because in die casting process, we mostly prefer for the low melting alloys like aluminum, magnesium, and the lead, tin, and zinc. Okay, so these kind of low melting point alloys can be easily cast by the die casting processes. Here, so in sand casting process, there is a limitation because we cannot cast thin sections sand casting processes because defect called misrun will happen. So the molten metal, because of the lack of fluidity and high heat transfer rate of the mold, the molten metal will not reach the fine or thin sections. Yeah, thin sections. So before reaching its the end point, the molten metal will solidify. Okay. So there will be the unfilled cavity, unfilled space will be there. Okay, that is called the missing. So these kind of defects can be avoided by applying high pressure. Here, the molten metal is injected at high pressure so that the molten metal will reach all the thin sections and all the places, okay, leaving no empty space. Okay, that is the beauty or that is the advantage of die casting process. So there are two types of high pressure die casting process. One is hot chamber die casting, and the second one is the cold chamber die casting process. So here you can see in this, so the diagram I have given for the die casting process. So this is the die. So the die consists of two parts. One is a fixed, another one is the movable. Okay, this is a fixed top, and another one is the movable top. So this die also has the ejector pins. Okay, the ejector pin is attached with the movable top. Okay, the main purpose of ejector pin is once the the casting is done, solidification is completed, the part has to be taken out. Okay, so we cannot simply take the part out. It's not possible. So by pushing the ejector pin inwards, okay, so it will remove the final casting. So not only ejector pins, there will be a vent hole is also there. Okay, because when the two arms will the two halves, the motor half and the fixed half will join. Okay, and it will create a space. Okay, that space is in that space there will be a there will be gases or air. Okay, that air has to be come out. Okay, when the molten metal is injected into the die cavity, okay, the air that is inside the mold cavity has to be come out. So that's why the vent hole is also provided here. And we have a nozzle here. So through the nozzle, the molten metal is forced, pressurized, forced into the die cavity. So and here you can we have a pot and we have a chamber and plunger. So this setup is called the furnace. Okay. So this is a furnace here, heating coils will be there. So this is a molten metal. Okay, the red color one that you are seeing in the molten metal. And here we have a plunger. So the plunger is more, the plunger moves downward position. It will pressurize the molten metal that is available inside the chamber. So it will pressurize and the molten metal will be sent into the die cavity. And the pressure is applied continuously till the solidification is done. Because in order to avoid the solidification shrinkage, in order to avoid the shrinkage, and in order to ensure that the molten metal is filled completely, we have to apply the pressure till the solidification. So, and the first one is the hard chamber die casting process. From the name itself, we can tell why it is called as hot chamber die casting process. So we can see the diagram here. Here, this is the die. This one is the furnace. Here, the die and the furnace are an integral part. Okay, so both are interconnected. Okay, and this particular type of casting is mainly used for the low melting point alloys. So what are the low melting point alloys? The zinc, lead, and tin. Okay, so these three metals can be easily cast using the hot chamber die casting process. Why particularly this low melting point alloys? Because here the die and the furnace are interconnected. Because since the molten metal is always in contact with the components like the gooseneck and the nozzle and the plunger. So molten metal is always in contact with these metals. So this gooseneck and nozzle, the plunger are made up of the same metal, made up of the metals like a gray cast iron, alloy steel, or ductile iron, or cast steel. So if it is so here the maximum temperature that the melting point of the metal that is used in hot chamber die casting is limited to 450 degrees Celsius. Here, the maximum temperature is limited to 450 degrees Celsius because this temperature won't affect the gray cast iron or alloy steel or cast steel because the steel has the high temperature because it's more than 450 degrees Celsius, like 1000, the melting point is around above 1300 only. So it won't affect this components. So and here the same here there is a position. So through this position, the molten metal that is available in the pot will get into this plunger, okay, get into this chamber. Once the plunger moves down, it closes this entrance, okay, and here it comes down, it will pressurize the molten metal into the die cavity, and the pressure is and then the plunger will continuously apply the pressure until the solidification is done. And once the solidification is completed, the plunger will move down. Plunger will retract back, and the excess molten metal that is available in the nozzle will again come into the chamber. Okay, and the molten metal available in the pot will come into this chamber. Okay, so this is how the process will continue. Okay. And this is the operation sequence. So in this diagram, you can see the operation sequence. Okay, first, both the die halves, one is the fixed die half and the mobile half. So with this, the two halves will be completely cleaned and the grease or some kind of the oil will be applied inside the mold cavity. It is applied in order to ensure that the finished, the solidified product will be easily taken out. Okay. Once this fixed and mobile hub dies are closed, and so this is step one. And the second step, the plunger will come down and it will pressurize the molten metal, and the molten metal will be sent to the die cavity. Okay, the pressure is applied till the solidification. So this is the second step. And in third step, so here the solidification has been completed and this plunger is retract back to its original position so that the excess material, excess molten metal available in the nozzle will again come back to the bottom, the melt pot or the furnace. Okay. Now the die half, the mobile die half is separated. Okay, so here we have the final component, final solidified part. Okay. So with the help of the ejector pin, so this is the core. Okay, this part is again retracted back, and this is the ejector pin. So by applying the pressure over the ejector pin, it will eject the solidified part. So this will be fourth step. So in the first step, the cleaning and the lubrication is done. The second step, the molten metal is pressurized into the die cavity, and the third step, the die is separated and the help of ejector pin, the final component is taken out. So this is the sequence of hot chamber die casting process. So in this slide, we are going to discuss about the cold chamber die casting process. So from the diagram itself, you can easily say what is the hot chamber and what is cold chamber. So why it is called the cold chamber die casting process? So this is the chamber. Okay, so this is the chamber, and so here you can see the chamber right here, and this is the plunger, and this is the die. Okay, so the die setup is same for hot chamber and cold chamber die casting process. So if this die setup is also has the mobile die half and the fixed die half, it also has the ejector pin. So this part is same. And the cold chamber die casting, why we are saying is here the furnace is separated. Okay, the furnace is not an integral part here. Okay. The furnace is separated, and here the main purpose of cold chamber die casting process is mainly used for the high melting point. Okay, some of the high melting temperature alloys like aluminum, brass. Okay, so these material can be cast, can be cast very easily. Okay, so this is a ladder, and so this ladder is used to take the molten metal from the furnace to the cold chamber. Okay, so with the help of the ladder, the molten metal is brought into the cold chamber. Here you can see the molten metal is poured inside the short chamber. And once the plunger is moves in this way, okay, so this molten metal will be forced into the die cavity. Okay. So here also the pressure is applied continuously till the solidification is done. So once the solidification is completed, the mobile die half will be retracted, and with the help of the trapping, the molten. So with the help of the trapping, the final component will be taken out. So this is the same process. The only difference is that the type of material that is being cast. Okay, that is the one. That is the first point. Not some die casting process. The low melting alloys like zinc, lead, and tin is cast. The tin is used. So in hot cold summer die casting process, there are some more high melting temperature alloys like aluminum, brass, where that is used to cast during the cold summer die casting process. So here you can see the operation sequence. So the first operation is the fixed die half and the mobile die half is connected. So both are connected here, and the molten metal is taken from the furnace. Okay, furnace with the help of the ladle, and here the molten metal is poured inside the short chamber. So this is the first step, and the second step, the plunger is moved in this way, and it pressurizes the molten metal to fill the die cavity. Okay, and the third step, the movable die half is separated, so that die half is separated, and the core is also retracted. Okay. Now, with the help of the ejector pin, the pressure is applied to the ejector pin. Okay, so this ejector pin uh, will push the molten metal from the movable die half. Okay, so this is our final product. So this is how the casting is being done in the cold chamber die casting process. Next, what are the advantages of die casting process? So in the die casting process, the very complex shapes can be easily cast. Okay, and it's a permanent mold casting, so that we are able to make many components with the same die. Okay. And a very small thickness can be easily filled because we are applying the pressure. We are, because the molten metal is injected into the mold cavity at a high pressure. It's the very high production rates because in sand casting process, for each component we have to prepare a mold. Okay, whereas in die casting process, a single mold can be used to manufacture the many components. So the production rate is very high, and here we can achieve the good surface finish because we are using the metallic dies. Okay, so good finishing and good dimensional tolerance can be obtained, and the life of the die is also very high. We will be able to produce around 3 lakh pieces for zinc alloys and 1,50,000 pieces for aluminum alloys. So the life of the die is very high. We will be able to produce many so many number of components from that. And inserts can be readily cast in place, and it is very economical for large scale production. So these are the few advantages of die casting process. And this process also has some limitations also. Okay, so now let us see what are the limitations of die casting process. So the main drawback or the limitation is the weight of the casting. Weight of the casting, that's the first thing, and the size of the casting. Okay, since we cast the low melting alloy, and the low melting alloys also has the lightweight. Okay, so the maximum weight of the rod to be cast is limited to 15 kilo, and this is not suitable for all materials. Okay, because the mold is made up of the metallic materials. Okay. So the 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 material, the metal that is going to cast, that process should have the low melting, the melting point of the molten metal, melting temperature of the molten metal must be less than that of the die material. So that is the main limitation. So we cannot use high melting point materials, high melting temperature materials in die casting process. Okay, so normally the zinc, aluminum, magnesium, and the copper alloys are die cast, and the air in the die cavity gets trapped. So that's why the vent holes are provided here. So air is the main, that is a big problem because both the dies are completely closed and there won't be any space between the the potting line. We call the potting line. So where you cannot find the potting line in the die casting process because it's very both the mobile and the fixed die halves are closely fitted. Okay, so the air that is inside the mold cavity has to come out, but in some cases it won't come out and it will create some problem, and it will create the porosity and kind of defects. Okay. And the dies and the machines are available. Machines are expensive, so it's very expensive, and the cost of manufacturing die is also very expensive. Okay. Yeah.